So this question 3, which is related to the moles exercise. So the equation for the reaction is shown that sodium is reacting with water to produce sodium hydroxide plus hydrogen gas is there. Calculate the concentration of a sodium hydroxide in gram per decimeter cube when 0.345 grams of a sodium is added to 50 cm cube of a distilled water. Assume that there is no change in volume. And use the following steps. You will always solve the moles question by the steps given in the question. So the first part, calculate the number of the moles of sodium added. We have the mass of a sodium in grams. So what we will use, first part, we always solve by using a formula. But which formula? What you can use mic, chat, or screen annotation. Which formula?
Mass in gram divided by molar mass.
So moles equal mass in gram divided by molar mass. Molar mass can be atomic mass or a molecular mass, because if it's an element, it will be atomic. Molar mass is atomic mass, like a metal is there, so molar mass will be atomic mass. But if it's a non-metal, the molar mass will be a molecular mass, except for group A. Now, mass in gram is equals to 0.345 divided by molar mass. So what is the molar mass of a sodium? You will use a periodic table. When you check the periodic table, sodium is written 11 and 23. So what is the molar mass? The molar mass is 23. 11 is a proton number. The mass number is always greater than the proton number. So it is 23. So 0.345 divided by 23. What's the answer? That is 0.015. So we get 0.015 moles are there for sodium. The second part, we have to determine the moles of sodium hydroxide. So first part is by formula, second part is by ratio. So what ratio we will take between which two reagents? So because we have the moles of sodium, so we'll take a ratio between sodium and sodium hydroxide. And you can clearly see that the ratio is 2:2 or 1:1. It's the same thing. Yeah, 2:2 is same as 1:1, because so sodium hydroxide, so we'll get the same answer. When the mole ratio is same, it won't make difference. Like 2 moles of a sodium require 2 moles of sodium, produce 2 moles of sodium hydroxide. So if we have 0.015 moles, it will be X. So how many moles we'll get? We'll get same as 0.015. It won't make difference. So X will be equal, because it's a cross multiply, like 0.015 multiplied by 2 and 2 is multiplied by X. So this will be 2X is equals to 0.015 times 2. And if you need X, so X is equals to 0.015 times 2 divided by 2. So it won't make difference. You will get the same answer. Is it clear, the first two parts? Anyone having a doubt or a question? Yeah, because when you multiply, see, when you cross multiply, as we are saying, the mole ratio is 2:2. For this part, sodium and sodium hydroxide, the mole ratio according to equation is 2:2. So if this is 0.015, this will be X. We cross multiply, so this 2 is multiplied with X. So this will become 2X. And this 2 is multiplied with 0.015. So 2 into 0.015 is equals to 0.03. But this 2 is multiplied, other side will be divided. So 0.03 divided by 2 will get the same answer as 0.015. So it won't make difference. When the ratio is same, what moles you put here, same answer you will get. If the ratio is 1:1, 2:2, 3:3, they all mean that the ratio is same. The next part, we need the concentration of sodium hydroxide in moles per decimeter cube. So how we can work out the concentration in moles per decimeter cube? So we have the moles 0.015. These are the moles of sodium hydroxide, and the volume of the solution was 50. Because like sodium is added to 50 cm cube, so volume of a solution is 50. But that is in cm cube. So if we need the concentration, the formula moles equal concentration into volume. But the volume must be in decimeter cube. So if we need the concentration, concentration is moles divided by volume. That will give us a concentration. So the concentration is moles, which are 0.015 divided by volume. What was the volume? The volume was 50 cm cube. But when we substitute, we want to convert into dm cube. So to convert the centimeter cube to decimeter cube, we have to divide by 1000. So 50 divided by 1000. So this will be 0.05. So 0.015 divided by 0.05. What's the answer for this? So we'll get
0.3.
So we'll get 0.3 moles per dm cube is the concentration. And if we want to convert the concentration from moles per decimeter cube to grams per decimeter cube, how to convert the moles per decimeter cube to gram per decimeter cube? We just multiply by molar mass. Like moles per decimeter cube multiply by molar mass, we'll get grams per decimeter cube. Because here is the concentration mole per dm cube, here the concentration gram per decimeter cube. So to convert the moles per dm cube to gram per dm cube, we just have to multiply by molar mass. And what is the molar mass of sodium hydroxide, NaOH? So you have to use the periodic table. Sodium is 23, oxygen is 16, and hydrogen is 1. So 16 plus 23 plus 16, 39 plus 1 makes 40. So the molar mass is 40. So if you want to convert the concentration from moles per dm cube to gram per dm cube, so what we have to do? The concentration in mole per dm cube multiplied by molar mass, which is 40. So 0.3 multiplied by 40, what's the answer? 0.3 multiplied by 40. So that's equal to 12. So the concentration of a sodium hydroxide is 12 grams per decimeter cube. Is it clear, this part?
Clear, sir.
So this was question 3 related to the exercise moles. Next session we'll do more from this exercise, like more this topic.